Okay, welcome back. We are on graphing sine and cosine functions using transformations. So we don't need to set up the big long t-table and plot 17 ordered pairs, points, to get the curve. We know if we have the 5 points and we know what our parent functions, the originals, look like, we can understand what the transformation is doing. All a transformation means is we're changing a number in the equation and it's going to change some component of the graph. So far we talked about changing the amplitude, the height of the graph, and we talked about changing the frequency, how many curves we draw. The third transformation we're going to talk about today is a phase shift. A phase shift is a horizontal shift. It means instead of the curve starting at 0 degrees or 0 radians, they're going to shift over either to the left or to the right. So they're either going to start ahead on a positive angle, or they're going to start behind on a negative angle. That's what a phase shift is. It's a horizontal shift. You will know you're going to have a shift on your graph where it's not going to start at 0 degrees or 0 radians because a number is going to be added or subtracted to the angle. So if you look up here, we know A stands for amplitude. We know the number connected to the angle x by multiplication. This is the frequency, how many curves we're going to draw. The number behind x that's either added or subtracted will be your phase shift. Now, here's the problem. If you add an angle, if you add a number to this angle, it's going to go in the opposite direction of what you think. Adding is going to shift your graph to the left. It's going to make it go backwards. Subtracting to that angle is going to shift it forwards. So it's the opposite. Adding goes to the left, shifts the graph back. Subtracting shifts the graph forward, it goes to the right. You'll know, if you look at all 5 examples we did in the previous video, there was nothing being added or subtracted to x. It was good old 1x or 2x or 3x or half x. So now we're going to see the difference. We have 3 examples to go through in the notes, so let's go slow. Example A is y equals sine x minus pi over 2. I want to learn how to graph that trig function. So I'm going to go through. I'm a creature of habit. I love to write everything out. What is my amplitude? My a value is in front of the trig function. It's understood to be the 1. So I know the height is going to stay positive 1 and it's going to go as low as negative 1. I want my frequency. My frequency is in front of my angle x. Well, in front of my angle x is a 1. So that's good. I'm only going to draw 1 curve. If I'm only drawing 1 curve, that's not going to change my period. My period is 360 degrees divided by my frequency, which means I'm going to need the 360 degrees to draw the whole curve. What's different here is right here. I have a negative pi over 2. Remember, x is an angle, so what's being added subtracting here is going to be an angle. And it can either be in degrees or radians. This one's in radians. So we would say our phase shift, which I'm going to abbreviate PS, we would say it's negative pi over 2. What does that mean? It means when we graph this, the negative means we're going to move in the opposite direction. We're going to move to the right. And pi over 2 means we're going to move 90 degrees to the right. So what that means, guys, is by subtracting this number from the angle x, instead of my sine curve beginning here at 0, 0, this curve is going to go to the right and start here at 90 degrees. That's what it's saying. The whole curve is going to shift to the right. So I have all my information listed. Now I'm going to go set up my axis. Which piece of information sets up your y-axis? Your amplitude. So that means I'm going to mark it as high as 1 and as low as negative 1. And I'm going to make sure those are equally spaced. If I count up 5 boxes to 1, I count down 5 boxes to negative 1 on my graph paper. Okay? I know I'm going to draw 1 curve. Now, it's my period that makes my x-axis. So I'm going to go down here and say to myself, okay, I need 360 degrees to make the curve. That means it starts at 0 degrees and goes to 360. This would be my starting point. This would be my ending point. But that's only 2 points. I need 5 points to make a curve. So halfway is 180, halfway is 90, halfway is 270. Okay, so from the previous video, if the period's 360, we would set up our x-axis with 0, 90, 180, 270, 360. But wait, are we starting at 0 degrees this time? No. We have a phase shift. So look at me. This is where the phase shift comes in. This curve is not going to start at 0 degrees because you're shifting everybody to the right 90. And if we're moving all these points to the right 90, it means we're physically adding 90 degrees onto all of these. So our first point is not going to be at 0 degrees, it's going to be at 90 degrees. Our second point is going to be at 180. Third point's at 270. Fourth point's at 360. The fifth point's at 450. So when I go to set up the x-axis, I'm not going to use radian measure for 0, 90, 180, 270, 360 because the graph got shifted to the right. I'm going to use my radian measure for these 5 angles. Well, we know this. 90 degrees is 1 pi over 2. 180 would be 2 over 2, which is just pi. 270 would be 3 pi over 2. 360 would be 4 over 2, which is 2 pi, which means 450 is 5 pi over 2. So there's my radians I'm going to mark my x-axis with. So everybody look at me. From that 0, this is 90. Okay, that means skip the same amount of boxes to get to 180. Skip the same amount of lines to get to 270. Skip the same amount of lines to get to 360. Skip the same amount of lines to get to 450. That's what I should see marked. So again, you take the period, you break the period up into 5 increments because you need to plot 5 points to make the curve. But then if there's a phase shift, you add it on this time, and that gives you the 5 angles you need to mark as radians. So now when we go to graph this, it's a sine curve, and we're graphing 1. Instead of starting here at the origin, it shifts to the right 90 degrees. So it's starting here at 90 degrees. And then it will follow the pattern. It will go up, hit the axis, go down, hit the axis. So that's what you're looking for. In your homework, you're looking to make sure when you graph this, it's starting at 90, it's ending at 450. You're making sure it went as high as 1 and as low as -1. If you use a graphing calculator, it's going to show a bunch of sine curves, and you're not going to know where one begins and where one ends. Okay, you need to understand the number here means something's going to happen to my graph. Let's make sure we understand what's happening. We shift. All right, let's try the next one. All right, I'm going to erase this one. I'm going to erase all this. All right, the next equation we have to go to phase shift is y equals cosine x plus pi over 4. All right, everybody with me? All right, what's our amplitude? Amplitude is A. It's always in front of the trig function connected by multiplication. It's still a 1. What does amplitude tell you? How high? We're going to go up 1, down to -1. Okay, what is our frequency? Our frequency is always the number connected to x by multiplication. It's also 1. So that's good. I only want to draw one cosine curve. Okay. Period is not in here. Period is a formula. Period is 360 degrees divided by the frequency, which is 1, which is good. It's 360. I'm going to need 360 degrees to make the complete cosine curve. Okay. Do we have a phase shift? Yes, we do. Here's our angle x. We have some number being added to it. Because this is an angle, this number here is either going to be degrees or radians. It's in radians. We are adding pi over 4. So the phase shift is pi over 4. What does that mean? What that means is adding means we don't want to go forwards, we want to shift back. We're going to shift this whole graph back to the left, and pi over 4 is shifting back 45 degrees. So instead of drawing this cosine curve starting at 0 degrees or 0 radians, it's going to start back here at negative 45 degrees. That's what that means. Okay? All right. We're going to do our setup. Here's my axes. Which number sets up the y-axis? The amplitude. The amplitude is 1. So we're going to go as high as 1 and as low as negative 1. So that's what we're looking for. Okay? Frequency means I better draw one cosine curve. Okay? To set up the x-axis, you need the period. The period's 360, which means this curve starts at 0, ends at 360, and I divide that into 5 increments. 180, 90, 270. That would be great if our curve was starting at 0 degrees. But now you have a phase shift. The phase shift says all of these points are going to move back to the left 45 degrees. So if I'm moving back, I'm not going to add, I'm going to subtract 45 degrees. So 0 minus 45 is negative 45 degrees. 90 minus 45 is 45 degrees. 180 minus 45 is 135 degrees. 270 minus 45 is 225 degrees. 360 minus 45 is 315 degrees. So the radian measure I need is for negative 45 degrees, positive 45 degrees, 135 degrees, 225 degrees, 315 degrees. Well, we know negative 45 is negative pi over 4. We know positive 45 is pi over 4. Now everybody look at me. Between negative 45 and positive 45, what would you do? There would be 90 degrees in there. Do you all agree? And between 45 and 135, there's 90 degrees. And between 135 and 225, there's 90 degrees. And between 225 and 315 is 90 degrees. So everything is equally spaced. So you're going to say to me, how do I get to 45 to 135? How do I make 135 in radian measure without doing the actual conversion we learned in the beginning chapter? Well, I'll think. Pi over 4, 1 pi over 4 is 45. 2 pi over 4 would be 90. So 135 is 3 pi over 4. And if you look, you're going from 1 over 4 to 3 over 4. So you're doing odds. So 225 would be 5 over 4. 315 would be 7 over 4. Okay? So now I know what I'm going to do to set up my x-axis. Now here's what worries me. Okay, you're on your graph paper. I'm going to put a bunch of blue lines here. All right. The first angle you want to mark is negative 45 degrees, which is negative pi over 4, which is over here on the left side. I don't care if you put it at the first blue line or the second blue line. It doesn't matter to me. Okay? Does not matter. But if I put negative 45 at the second blue line, I'm saying between negative 45 and the axis here, I skipped a spot. So when I go to put positive 45, I can't put it at this blue line. I got to skip a spot. Makes sense? Because it's got to be symmetrical. So from here, 0, that's back 45. I skipped a line. From here, 0, I skipped a line and went ahead 45. Now I got to get to 135. Does that mean I just skipped one line? No. Because between here and here, count how many blue lines I have. 1, 2, 3, 4. So I got to go 1, 2, 3, 4, and that's where 135 would go. And then I'd go 1, 2, 3, 4, and that's where 225 would go. And I go 1, 2, 3, 4, and that's where 315 would go. So the biggest mistake we make when we set up our x-axis is not making sure all our radian measures here are equally spaced. Here's negative 45, and here's positive 45. There is 1, 2, 3, 4 lines between them. So you have to do that for everybody. Now we're ready to graph. We're drawing a cosine, so a cosine should begin up at x is 0. We should go up to 1. We're not starting at 0 because we phase shift back 45. So at 45, we start up at 1. Then at positive 45, we hit the axis. Don't hit the axis here. 0 is not in your radians. Then at 135, we go down to negative 1. 225, we hit the axis. 315, we're back at 1. And there's your picture. So guys, the biggest mistake we make is we're labeling these 5 radians because that's where the 5 points have to be plotted. All right. I think we have one more to look at. Okay, the last one for phase shifts. All right, your equation is that you want to graph y equals 2 sine 1/2 x minus pi over 2. All right, let's go slow. What's our amplitude? Well, amplitude is in front, it's 2. We know we're going to go as high as 2 and as low as negative 2. Okay, what is our frequency? It's in front of the angle by multiplication. It's a half. We're only going to draw half a curve. Are we going to need to plot 5 points then to draw half a curve? No, we're only need 3 points. Okay. All right, the frequency affects our period. So we got to find our period. Our period is always 360 divided by our frequency, a half. We've done this previously. What's 360 divided by a half? 720 degrees. For this equation, we are going to need 720 degrees to make the full curve, just so y'all know that. Now, do we have a phase shift? Yes, we do. Here's the trick. It's not what you see. Most of you are going to tell me the phase shift is negative pi over 2, and you're going to be marked wrong. Because if you read your definition, it says in your notes to tell me the phase shift, the frequency has to be the number 1. Is that the number 1? No. So that's not the phase shift. So you're going to say, well, what do I do? Okay, well, we're going to use algebra. We know how to change a half to a 1. We just got to get it out of there. If it's connected by multiplication, what do you do to get it out of there? You do division. We're about to factor. We're going to rewrite this. This is rewritten as y equals 2 sine. I'm going to pull out the half. I'm going to divide out the half. And a half x divided by a half is just x. So now we have a 1 in front. And what is negative pi over 2 divided by 1/2? Well, dividing fractions, easy as pie. Flip the second and multiply. Dividing by a half is multiplying by 2 over 1. The 2's would cancel, and that would leave you with negative pi. I did not change the equation. I just rewrote it so I could tell the phase shift. Everybody look. Is the amp still 2? Yep. Is the frequency still a half? Yep, that number is still connected to x by multiplication. But now when there's a 1 here, here is your phase shift. Your phase shift is negative pi. What does that mean if your phase shift is negative pi? Well, if your phase shift is negative, it means you're going to move to the right. Pi is 180 degrees. So all we did to find the phase shift is if we have a number in front of our angle x connected by multiplication, and we have a frequency, we need to factor it out so we can get our phase shift. Okay, that's all. It needs to be written in factored form. That's why you had to learn Algebra 1. Now I have everything I need to go get our graph set up. Okay, which number affects our y-axis? The amplitude. So we're going to go as high as 2 and as low as negative 2. Okay, frequency means we're only drawing half a curve. To draw half a sine curve, half a curve does not require 5 points. It only requires 1, 2, 3. So we're only going to have to plot 3 points. To plot those 3 points, we got to start with our period. Now, our period's 720, which means this curve, if it started at 0, would end at 720. And halfway would be 360, and halfway between 0 and 360 would be 180, and halfway between 360 and 720 would be 540. Okay? So if we were drawing this curve, if it had a frequency of half, we would start at 0 and go all the way to 720. But is our curve starting at 0 degrees? Nope. You told me we had a phase shift. Minus 180 means we're shifting all of these points to the right 180, which means we're going to have to add 180 degrees to all of them. So we add. We get 180 degrees, 360 degrees, 540 degrees, 720 degrees, and that would be 900 degrees. Now we got to convert it to radians. But do we need to convert all 5? No, because you only said you're drawing half a curve. I only need the first 3. Well, we know 180 is 1 pi. We know 360 is 2 pi. So 540's got to be 3 pi. It's going in a pattern, 1, 2, 3. So now we know how to set up our x-axis. Whatever you skip, here's 0. I don't care how many you skip, just be consistent. There's pi, 2 pi, 3 pi. Okay, we're drawing half a sine curve. A sine curve is supposed to begin at 0 degrees, but you're phase shifting it. So you're beginning here at 180. Then it goes up to 2, and then it hits the axis. We only should draw half a sine curve. That is it, half a sine curve. Again, if you use a graphing calculator, sweethearts, it's not going to draw you half a curve. It's going to draw you a ton of curves. And then you're not going to know where one begins and one ends. So using a graphing calculator is not going to be an aid in this section. It's going to really actually confuse you more. You need to understand by changing the numbers in the parent function and making these numbers be different makes a change, a transformation, and you got to understand what that is. Okay, we have one transformation left. I'll catch you in the next video.